We're going to be looking at some box plots, and they're also called box and whisker plots. Now, you can see here I'm looking for a bunch of things: the median, the first quartile, third quartile, interquartile range, and the outlier, if there is one present. Um, I really like this in terms of understanding what variation is. This is a great picture of understanding variation. You'll see what I mean in a second when we break things down. Um, if you can tell, this little piece right here, it's kind of easy to distinguish from everything else. You've got these two blocks on either end of it. This piece right here is going to be your median. So your median temperature in this case is 49 degrees Fahrenheit. Now your median of what data set? We don't really know. There's no data set here. There could be, for all we know, this could be measuring 1,000 days. It could be measuring, 15 days. We don't really know how many are there. So it's tough to see what the mean would be or what the mode would be, but we know the median is 49 degrees. Quartile 1 is also easy to tell just by looking very quickly at this box and whisker plot. It's going to be 41 degrees. This is your first quartile of information. Of course, your first quartile is always going to be smaller than your third quartile. So there's 41 degrees Fahrenheit. And you can probably predict, based on the fact that the first quartile was marked by this line right here, where the third quartile would be. And it's going to be on the other side. And that's going to be 53 degrees Fahrenheit. Now bear with me because I actually made this this number line here. So if it looks like, well, Mr. Surrender, this could be 53.1 or 52.9. We're going to round this to the whole number. It's 53 degrees Fahrenheit. The interquartile range then would be 12 degrees Fahrenheit. We would subtract 53 minus 41, and we would get 12 degrees Fahrenheit for a range. And it's nice too because you can see with the subtraction here, we've got a number line, so you could even count the spaces from 53 over to 41, and you recognize that there are 12 spaces between those numbers. To get the range, this is where the whisker part of box and whisker comes into play. This right here, this little string, is a whisker, and this right here is also a whisker. So the range, of course, we calculate that by doing the highest number minus the lowest number. The highest number in this data set is 55 degrees. So we would do 55 minus 36, and you can see 36 would be right here on the end of that whisker. 55 minus 36 would get you 19 degrees Fahrenheit for your range. Now, just in terms of conceptualizing this, we can come up with a lot of different observations on this data set. You could say that this right here is the 50 percentile point of the data. So the median is always the middle number when they're in order, and so this is the 50 percentile point. And this right here, the first quartile, represents the 25 percentile point. And then way over on the right-hand side, this is the 75 percentile point. And of course, this represents where your data numbers from 0 to 25%. Those are your lowest 25% in your data set. And then finally, the point right here would represent, at 55 degrees, the 100%. So your middle 50% of your data set is from one end of the box to the other end of the second box. That's your middle 50% of your data set. And that's where we get this term interquartile range from. And it's between the quartiles, obviously. And you can see that it's the middle 50%. The 100%, though, is from the 0 all the way to the other end of the whisker. And that's your range. So your range is always going to be a bigger number than your interquartile range. And you can see that because when you calculate your interquartile range, this point from 55 to 53 isn't included. And also this point from, I guess it starts at 36 and goes to 41 degrees Fahrenheit. So that's why your interquartile range will always be a smaller number than your range, or at least equal to your range. There are rare cases where the interquartile range and the range, I guess, could be equal. So you can kind of get a picture there of how these numbers work. And you can see this box is a lot bigger than the box on the right. And the reason for that is that these numbers from 41 degrees to 49 degrees Fahrenheit are a lot more spread out. There's greater variation. Whereas the numbers from 49 to 53 degrees, they're a lot closer together. So maybe in this data set you have I'm just making this up off the top of my head, but maybe you have a number like 41 degrees and 45 degrees and 49 degrees. They're kind of spread out. Whereas these numbers, maybe you have like a 49 degrees, a 51 degrees, a 51 degrees. You know, they're not that spread out. These are like 4 apart in my example, and these are like 2 apart. Just a hypothetical example. Then there wouldn't be an outlier in this case, and I'll explain outliers on the next slide. So speaking of that next slide, you can see here, it's a similar setup. You could probably, hopefully, predict what the median would be. See if you can pause the video, predict what the median would be, the quartiles, the interquartile range, and even try the range and outlier in this one. Okay, the median is 35, and they don't give us a title in this graph, so we're just going to call it 35. There's no temperature or anything like that, so we'll say it's 35. And I just got that because that's where this middle point is. The first quartile is 25. The third quartile is right up here at 55. The interquartile range is, of course, these two numbers subtracted. So quartile 1 subtracted from quartile 3 would leave us with 30. 55 minus 25, right? Now the range is where this gets a little more complicated. You see the star right here? That's basically the symbol for there being an outlier in this problem. So the outlier is actually at 105. So our highest number is 105. And that's kind of the wolf in this whole idea of box and whisker plots. So 105, and the lowest number would be 15. And when we do this out, we'll get 90 for the range. And then the outlier, of course, would be 105. Again, just to illustrate that point that we were talking about before, about what this tells us about the variation in the data, in addition to us already knowing the interquartile range, the range, and the outlier, the numbers are closer together in the first quartile to the median, as opposed to from the median to the third quartile. They're a little bit more spread out, and you can tell that based on the size of the box. And you can even see from the third quartile to the end of the data set, the numbers are more spread out from here to here. And especially if we consider from the third quartile all the way over to the outlier. So hopefully that gets through the points to you about the key ideas behind box and whisker plots. I'll show you in the future a video on how to put together a box and whisker plot.